Good morning all. In this lecture video we are going to discuss about the brute force technique. Uh, so brute force technique is a straightforward approach for solving a smaller problems, which is basically based on the problem statements and the definitions of the concepts involved. The examples we can solve under this brute force approach is computing a power n, computing n factorial, multiplying two matrices, searching for a key of a given value in a list, that is linear search, and so on. Like all the smaller problems like multiplication of two matrices, sum of two matrices, sum of n numbers, all these problems can be solved under a brute force technique. Next we discuss what is an exhaustive searches. The exhaustive searches, uh, uh, it is also a brute force technique, but it will especially applicable for solving a combinatorial problems. So the approach behind in this is you have to enumerate and evaluate all solutions, and finally you have to choose the solution that meets some criteria. For example, whether it is the smallest or maybe largest one. But you can get this obvious solution, but sometimes it is slow. The reason is that is you have to enumerate and evaluate all solutions, so that it will take time. So that's why it sometimes the efficiency will be very slow. So in the more detail, what is an idea behind in this exhaustive searches? You have to generate a list of all potential solutions to the problem. Then you have to select the one which satisfies both the objective and as well as the constraints of the problem. Because I have already told it's applicable for solving an optimization problems. Okay. So it can be an either minimization or the maximization, and then all the problems will have some constraints. If the solution doesn't meet the constraints, we can say that is an infeasible. So the solution that meets the constraints, we can say it is a feasible solution. So among the feasible solutions, select the one which satisfies the objective. So there are several problems which can be solved under this exhaustive search: traveling salesman problem, knapsack problem, assignment problem, and graph algorithms, DFS and the BFS. So first we'll discuss what is a traveling salesman problem. What is a TSP is given n cities and a distance between each pair of city. We have to find out the shortest tour which visits all the cities exactly once before returning to the starting city. So the traveling salesman problem can be framed as a weighted graph problems, whereas the cities are represented as a vertices and the distance between the cities are represented as an edge. Okay, so A is a one city, B is another city. The distance between these two cities is the 2. Likewise, you have to transform this problem into one weighted connected graph. So we can say this problem formally we can say it is the find the shortest Hamiltonian circuit in a weighted connected graph. So how we are transforming this into an Hamiltonian circuit? In this, a Hamiltonian circuit is a simple path or a simple cycle in which all the vertices has been visited exactly once, whereas the first and the last vertices should be the same. So how this problem can be solved using this exhaustive searches? What's exhaustive search says that you have to generate all the combinations of these items. So when we start at the tour A, you can visit the next city B, next city C, from C to D, and again you have to return to the starting city A. So you have to find the total cost. Okay, the edge distance between A to B, B to C, C to D, and D to A. The cost is 70. So likewise, you have to generate all the tour combinations. Among this, we have to select the one which is having the minimum tour length. So the efficiency of this problem is this. the permutations of this tour, that is BCD. So we can say it is a big O of n factorial. The next problem is knapsack problem. So what is the knapsack problem is, given n items, along with the weight of this item W1 to Wn, and the value or the profit of the item V1 to Vn, and the capacity of the sack W, and the problem is find the most valuable subtypes of the item that fit into the knapsack. So for example, they have given the knapsack capacity is equal to 16 and the 4 items along with the weight and as well as the value. Okay. So we are supposed to solve this problem using exhaustive search technique. What is exhaustive search says that you have to generate all the subsets. Among that, you have to select the one which satisfies the constraint and as well as the objective. So the first subset is you are considering the first item alone into the sack. So the total weight of the item is 2. The value is 20. The next subset, you are considering the second item alone. You are not placing the item 1 or 3 or 4 into the sack. You are placing item 2 alone. Then you have to consider what is the total weight and as well as the profit. Then if you are considering the third item, what is the value, profit. Fourth item. So this is the single item. Then you have to go for the two subset item. If you are considering the item 1 and 2 together, so you add the weight of these two items. So 2 plus 5 is 7, the total weight. Then add the value or the profit. So 20 plus 30 is 50. Then if you are considering the item 1 and 3, then you add the weight of the first item and the third item. 10 plus 2 is 12. Likewise. Then if you take the item 2 and 3, the weight is 50, the profit is 80. For example, again at the moment you cannot conclude that this is going to be the optimal solution. So all these are the feasible solutions. For example, if you are considering the 3 subset item, that is 1, 2 and 3, if you add all these weights, so 2 plus 5 is 7, 7 plus 10 is 17, but the solution is not feasible. So since we are violating the constraint of the problem, the total weight is exceeds the capacity of the sack, whereas 16. So it is not feasible. So likewise you have to generate all these. So among this you have to find out the one which is having the most profit. So this is going to be the most profit, that is $80. Okay. So the optimal solution to this problem is you can place the second item and the third item into the sack with the most profit, maximum the profit is 80. The next problem is the assignment problem. What is the assignment problem is there are n people who need to be assigned to n jobs, one person job. Then the cost of assigning person I to job j is C of ij. Find an assignment that minimizes the total cost. So for example, if you consider this 4 persons and 4 jobs. Okay. You are supposed to solve the problem using this exhaustive search. What's exhaustive search says that you have to generate all the combinations of the assignments, compute the cost, then you have to select the one which is having the minimum assignment cost. The constraints of the problem is one person to one job. So that is you cannot assign more than one job to the person, and the same way the same job cannot be assigned to more than one person. The objective is the total cost should be known. So we have to generate all the combinations now. What does this combination says that you are assigning person 1 to job 1, person 2 to second job, person 3 third job, person 4 fourth job. So you have to add all these costs. So 9 plus 4 plus 1 plus 4, that is total cost is 18. The next combination is 1, 2, 4, 3. The first person first job 9, second person second job 4, third person fourth job 8 the cost, fourth person third job the cost is 9. So if you add all those things you will get 30. So likewise, you have to find out all the assignments. Among these, you have to select the one which is having the minimum. So we can say this is the among all these assignments, the optimal one is 2, 1, 3, 4. 2, 1, 3, 4. For the first person, second job, second person, first job, third person, third job, fourth person is fourth job. So 2 plus 6 is 8, 8 plus 1 is 9, 9 plus 4 is 13. So the total assignment cost is 13. That is going to be an optimal solution. So how we have taken that is going to be the thing is, in each and every row you select the minimum value. So 2, then in this row 3, in this row 1. But if when you come to this selection, it is violating because you are assigning the same job to more than one person. So when you compare these two values, one is the minimum. So in this row you go for the next minimum value. The next minimum value is 4. Here also you are violating. You are assigning the same job to more than one person. So the next minimum is 6. So that's why the possible minimum assignment is 2, 6, 1. Then in this row also the minimum value is 4. So the combinations is again this n factorial. The exhaustive search, how we can conclude is it's going to run in a realistic amount of time, but it is applicable only for a small instances. Okay, but sometimes you have some better alternatives also. These are the Euler circuit, shortest path, some problems. So exhaustive search or its variation is the only known way to get exact solution to the NP hard problems. The finally we'll discuss what are the advantages and the disadvantages of this brute force. As we say that from the definition, it's a simplest straightforward approach, so it is widely applicable and as well as very simple, but for some problems or important problems it yields some better efficiency, for example sorting and the string matching problems. But the improvement may be too hard, because if we say that as efficiency of the bubble sort is n square, from that you cannot able to improve the further. You cannot reduce it to n or n log n. The weakness of this is which is going to rarely yields efficient algorithms. Some brute force algorithms are unacceptably slow, not as constructive as some other design techniques. Thank you.